Hello, Violeta. We are here very happy to start again the Icebreaker Conversations 2025 after a very hectic Antarctic season. We were in the field up to February, so we are starting in March with this conversation. Agus, how are you?
Very, very well. Thank you, my friend. What
Thank
about
you so
yourself?
much. Thank you so much. And we have our guest today that I'm so happy to introduce. Violeta is a colleague. She's a geologist. She studied tourism in Buenos Aires and then she moved to Ushuaia, the end of the world, to Tierra del Fuego to study geology. And she's been traveling to Antarctica in educational trips. But let her tell us about it. Hola, Violeta.
Hi everyone, how are you?
How's it going?
Great, great. A little bit nervous, but I'm good. I'm good.
No way. We're really looking forward for you to tell us about Antarctica geology side. We always get lots of questions like, how did this come to be here? And is it true that with all these new dinosaurs and fossils encounters we've been having lately, we always get the questions if it's true that it was a forest, if there were birds and trees and so on. So we are looking forward to hear what you can tell us about these questions.
Yes, we will try to answer those questions during this presentation, and I'm gonna do my best. Just 1 minute, I'm gonna take my water from my mate because I'm still
Mate,
Argentinian.
of course, please do. Mate is very important for Argentinians. Instead of drinking coffee or tea, we do mate and we cannot live without it. Right?
Especially when we have to be sitting on the computer. It's like a best buddy.
Definitely. We all need our caffeine fix.
Totally, this is my fuel.
There you go. Now we're ready.
Now I can start.
Great.
It's always hot water, never boil. That's
Never.
the key. So, if we are ready, we can start trying to answer.
Mm-hmm.
Yeah. Sorry.
Go for it.
Okay, great. So we are looking my presentation in this moment.
Mm-hmm. Yes.
Great. So we have an iceberg and penguins, my favorite. So let's talk about Antarctica and this question that we got, and we try to answer that are how and when did Antarctica come to be? Mm-hmm. Was Antarctica ever a green land full of life? And why did Antarctica freeze over and when did it happen?
Mm-hmm.
So to trying to answer those questions, we need to have a few concepts in our mind that are not so usual for everyone. And the first one is the geological time. The formation of the Earth was 4.6 billion years ago, and that's a lot.
That number never fits in my brain. I cannot think that way, but yeah, a lot.
Totally. That's why we will try to make it simple. We have this to the right, this chronostratigraphic chart. That is what scientific use to organize time from the beginning, from these 4.6 billion years ago to our present. And this table was made by scientific with different kind of rocks, different events that they found, different fossils. But for us today, it's going to be easy if we try to talk about this whole time, putting in one day, 24 hours day, the whole history of the Earth.
Okay.
From the beginning. Yes, I think it's easier to figure it out and to have in mind this scale of time that is blow your mind. So if we start looking this day, we have the moon just 10 minutes after the Earth was formed. But if we keep looking, yes, we can get to the first bacteria that is 9 hours after this Earth was formed. Okay. And if we keep looking to these hours in this 24 hours day, we will find the plants, for example, appear like 21 hours after. Yes.
Okay.
People, we appear like just in the last moment. Can you see my cursor?
Yes, I can see. Yes, I can see it.
Great, great. So humans, we are really new on this earth. Yes, it's just a few seconds ago in this day of life in Earth. Dinosaurs, of course, always. They appear here 22 hours, almost 23 hours. And extinct just a few 20 minutes ago in this timetable. So something that is really old for us, and we talk about dinosaurs, and it looks like really, really far away. In the Earth clock is actually not so far away.
Not so far away.
I write here. See, can you see how many zeros? It has 1 billion of years, so
Yeah,
it's a lot. So what I'm trying to say is the Earth time is been long, and imagine that happened a lot of things during this whole time. Yes, this 4.6 billion years ago. So having this in mind, the other concept that we need to have in mind is about the continental drift.
Okay.
This theory is old, not so old, but 100 years ago, more or less. This man, Alfred Wegener, he was one of the first ones to present this theory that talk about the continent can move, and in some point they were all together. He found a lot of evidence of this, like, well, at the beginning, the continental feet. If you take South America and Africa in Google Maps, you can see that
totally.
peaks. Then the rocks that they found in each part of this continent were the same age. They look similar or just equal. So maybe they were formed together. The next evidence is going to be the fossils, terrestrial or land fossils, land animals that they couldn't walk through this continent from America to Australia. Yes. And they found it all around these continents, the same fossils. Then we have a paleoclimatic event, glacier times that affect this continent. So these are the proofs that he found to think about this theory, but he couldn't prove how it happened, which ones were the mechanism to make possible this, the drift of the continents. So a few years later, after the Second War, science started developing new research methods, and they start studying the Earth and the internal part of the Earth. We are not going deep in this, but we need to know there's three different ways that the plate tectonics, they interact between them. In some points, like in the Atlantic Ocean, there's a ridge, and it's been creating some continental ocean crust all the time. So, but if this happens, in some point it's growing the Earth, so in some point must be being destroying, because if not, the planet is start growing, and that is not happening. So in some parts of the planet, there's places where the plates are going inside the Earth again, so they're being destroying. So this is part of the dynamics of the tectonic plates. And this theory come to complete the whole theory about the tectonic plates, that they move, they form continents, bigger and smaller in some point. They get together and they separate.
Okay, so plate tectonics would explain the part that Wegener couldn't. Like, why would they?
Exactly. The mechanism of how they move.
Great.
He saw this idea. He has this idea of one big continent, a supercontinent, but he couldn't explain how it moves. He found the evidence, but couldn't explain that. So after 1945, they start studying the Earth, and they get to this information on this data that they see. It works for the tectonic plates theory. So we have timetable, and we have the tectonic plates to have in mind. So we keep going about Antarctica. Just 1 second. So we have a map from Antarctica, and when we talk about Antarctica and we see the rocks of Antarctica, remember this is a geological
Yes,
chat.
rocks.
There's no way to don't talk about rocks. And the age of the rocks. In Antarctica, we have found different ages in the rocks. We find the oldest one is more than 1,000 million of years, 560, 500, between 500 and 600 million of years. Then we have 251, 200 million.
Mm-hmm.
Actually, really old.
You
And to
both,
explain how Antarctica come to be,
Violet, you're breaking up a little bit.
sorry?
You're breaking up a little bit. Let's see if she can come back.
Here.
I know you're there. We need Violeta.
Okay, I know. No worries. She'll come back.
See, she was breaking up a little bit, but I didn't want to interrupt because sometimes that
It just, yeah,
comes
fix
back.
the case. No worries. She'll be
There
back.
she is, right?
Yeah.
Ay, pobre Violet, she must be freaking out.
Yeah. No worries. We will all survive, you know. Technical issues is part of our
But
life.
being in Ushuaia, let's tell everybody, being in Ushuaia and like winds and Ushuaia and internet are usually clashing with each other all the time. And someone is saying that today is very windy in Ushuaia, so it's probably one of the reasons. Thank you,
Yeah.
Cecilia.
Anything could be, yeah.
And they're saying we expect 100
today.
kilometers per hour today. Okay, yeah, probably that's what's going on with Violeta.
Yeah. No school today in Ushuaia, I think.
No, and I can see Violet trying to connect and disconnect
It's
again.
coming up and down. Well, we'll give it a try, and if not, we'll
reschedule.
if to a better day. Yeah, absolutely. Yeah. Anyone knows a joke?
I do, but it's about biology, not about geology. So I won't do it. See, I can see she's trying to come back again.
Ceci has a good connection. Maybe we should make Ceci a presenter.
See?
Talk a little bit about Antarctic trips or something like that. Now she's freaking out.
Classes were suspended today because of the winds.
Yeah.
My.
Yeah. Very, very, very windy. Well, I have to say that the Antarctic geology is always very, very fascinating. When you are there, when you travel to Antarctica, when you arrive to the place, and the first things you see, it's like mind-blowing. I guess we all remember our first day, our first time seeing the first islands. I do, especially because I was seasick the whole trip down.
Oh no! Violet, there you are.
Hey, there you go.
I'm sorry.
No problem.
It's okay. No worries. No worries.
We were talking about that Ushuaia and wind and internet don't go well together. And today in particular, there's a really bad wind forecast, right?
Yes, there's yes, actually school
was canceled.
Yeah.
But anyways, we were paying attention and you were saying that in Antarctica, we have different types of rocks of different ages. That's where you were. Okay.
Yes. And because we saw that one of the rocks were like really old, 1,000 million years ago, we will start in this. Can you see my presentation?
Yeah, we're in it.
We will start in this point with Rodinia supercontinent. So the idea of this is to see that Antarctica wasn't in the same place the whole time. It was in different places in this map. that was reconstructed by scientists. You can see that East Antarctica was, this is Ecuador, the Ecuador line. So it was in the north part, in the north hemisphere. Yes. So the position was totally different than what we see now. This point, in this moment, we are in the chronostratigraphic chart. We are here in the blue circle. Yes, we are talking about 1.3 billion years ago. So it's a long time ago. In our clock is 18 hours after the form of the Earth. Okay. The Earth was formed. Sorry. So we keep going in time, and we are in Pannotia, another supercontinent. In this case, we are farther or closer to us in the time, but not so close. We are talking about 500 million of years ago. Antarctica is still in
the northern hemisphere, let's say.
No, this is 0. This is Ecuador. So
okay. Got it.
It moves.
Okay.
It moves a little. It's in our hemisphere now, but it's still farther away from the South Pole.
Yep.
We are closing in time. The Rodinia supercontinent breaks up, and then start netting in different pieces, and we have Pannotia supercontinent again. And then we keep going in the time. And we have a supercontinent that is more known, maybe.
Gondwana, yes.
Gondwana, yes, we got here. Gondwana was formed, 480 million of years ago. It was a supercontinent. We can see that it was formed from South America, Africa, Arabic Peninsula, India, Australia, and Antarctica is here. From the South Pole, you can see Antarctica is far away yet. Yeah, we are closer in the time, and we keep going a few more millions of years, and we got to Pangea. Pangea is going to be one of the most important ones. This supercontinent was formed by Gondwana, Africa, South America, Australia, those continents, plus the Laurentia in Laurasia, that is the northern continent, United States, Canada, Groenlandia, and part of Asia also. This, in the timeline, we are more or less 260 million years ago. Antarctica in this time, can you see this is the South Pole, and Antarctica is closer, it's getting closer to the Yes. So, was Antarctica ever a green land? Was Antarctica ever a green land full of life? The answer is yes. We're going to stop. We're going to stop in this period during Pangea, during this huge continent, and we find fossils in Antarctica from a really particular flora that the name is Glossopteris. This kind of plants doesn't exist anymore. These plants were plants that they didn't make fruits, but they make seeds. And in this time, the weather in the whole planet was totally different. It was a warm period where forest was everywhere, and these kind of plants were found in Gondwana, part of Pangea. So in the south part of this supercontinent, across South America, Africa, Antarctica, and Australia. Fossils of these plants were found in all these continents, and this is one of the main reasons, or this is part of the evidence that Alfred Wegener used to prove that it was a whole continent. Yes.
And Yoli, I have a question. In the picture, I can see ferns, something that looks like Araucaria, and is all of this family of plants that were present in that time?
There was a lot of kind of. Glossopteris is the one that is best preserved, and it's important. This Glossopteris in particular, there were trees, bushes, and seeds. And fern also. the most important of this flora is a lot of things. The trees, the farms, is that disappear and disappear in a short time.
Oh.
So for geologists, it's amazing. For this work, it's amazing because when you find these kind of fossils in a rock, you can say how old is the rock, or at least where you are in time. Yes. In this case, all these disappeared after a huge, massive extinction. There was 5 big extinctions around the world in the Earth in different moments. This one is not the one that took the dinosaurs. Is earlier extinction that was massive. There was also a meteorite. Meteorite is okay.
Meteor, yeah.
Okay, meteor that landed in Antarctica. Huge one, and also a lot of volcanic activity that make that more or less 90% of the life disappear in that moment. Also Glossopteris, this kind of flora. So most of the, not most, but a lot of the fossils that we can find in Antarctica belong to this kind of flora.
Awesome.
Are we okay?
Yes.
Great. So we keep going in time, and Pangaea keep going. It's a huge supercontinent, but also start splitting in different parts. First, the north part of Pangaea, all North America and Asia start separating. This took like 100 million of years. It's a really slow process, but Pangaea start breaking up. Yes. After more or less, 100 million of years ago, the Atlantic Ocean start opening, and Antarctica start taking this south position. It start going to the pole, the South Pole. But at this time, 100 million years ago, there was forest. At least 80 million years ago, there was Nothofagus. You know what is Nothofagus?
Yes, of course. Our favorite. Patagonia's favorite.
Exactly. No, our forest in Ushuaia actually could be a landscape that could occur or happen in Antarctica 80,000 years ago.
That's amazing.
80 million years ago, sorry.
So the people witnesses when they are in Tierra del Fuego before going to Antarctica, it's a good thing to say like this that you're seeing now. It's what probably happened down there when it wasn't down there. That's amazing.
Sí, and the weather was totally different. Yes, the weather is not something that is just because of the place where it's Antarctica now. Is also the current seas affect the weather. Also the carbon dioxide in the atmosphere take place on this. Sorry, really difficult words in English.
No. Perfect.
So those things are parameters that that take place when we talk about weather or climate change in this case. So in that point, Antarctica was in a southern position, but still has forest, and the weather was warmer, much warmer than we in the whole planet.
It was in a southern position, but the south of the Earth wasn't as cold as it is today.
Yes, okay. Totally. Because of the sea currents that didn't work, that works now. We are going that point. Okay. We are going that way a little bit farther in the time.
Okay.
So we are here 55 million years ago. Just it looks more like we know it. Continents are separated. Australia is still close, but is going farther from Antarctica. And then we got here to the last phase of this breaking up of Pangaea, the worst breaking up ever. We have after the continents start separated, each one, the currents of the ocean start working. And if you take a look of this one, you have Antarctica that is totally isolated.
Yes.
Surrounded by oceans. Yes. And now the weather start changing because of the currents of the sea, because of the position now is south in the pole, so the sun never gets to the continent. And also the other point that is really important is when closed between South America and North America. Yes, and that changed all the current seas, and the temperature of the whole planet start going low and low. Antarctica start get freezing and start getting glaciers, and this is like something that feed himself, because you start getting glaciers. Glaciers are white. The white, repels the light. Imagine when in summer, when you get some white clothes, you do it because you don't want, some black clothes,
Yeah.
it absorbs the sunlight. So it happened this. In Antarctica, it happened something similar. Albedo is the
Yep, that's the
name
word.
of this. See, that works. Great. So sun star,
Reflecting.
reflecting the ice. So warm never gets to this area and start get freezing and more glaciers. More or less 13 million years ago, Antarctica was covered, most of Antarctica was covered of ice. The last register of Notofagus forest disappeared more or less in that time. And the Notofagus just stay in Tierra del Fuego, the forest. Yes? Okay. So if you go to Antarctica, if you have lucky and you can go in the peninsula, you have the Shetland Islands, and in the Shetlands, there's a big island, and the name is Livingstone Island. And in this place, there's a point that is Hannah Point and the Walker Bay.
Yes.
And if you go there, not all the cruises do it, but if you have lucky, you will find some fossils that these ones that belong to 80 million years ago, to that time of the forest of Notofagus and
80
others.
million years ago. 80
million, I think.
Million, yeah. 80 million years.
Millions. Always millions. The numbers are big ones.
Okay. That's awesome.
Yes. So this is one chance if you are traveling to Antarctica. So I think I make it too short because I get nervous and I speak too fast.
No. It was amazing. Thank you so much, Viole. And actually, I have a couple of questions.
Yeah, we can come back to the
No,
others.
absolutely. The good thing about being the one that presents is that you always get first in the line of questions. No, but I won't. Do you have any questions?
I did that, but they were all answered while Viole was talking.
No, great.
So yeah, one of my questions was, when I saw, it's the first time I see that in one of these sketches that Africa was in the South Pole position 400 million years ago, and I was looking at that and saying, oh, wow,
what?
I never pictured that, and then I thought, was it covered with ice? And of course not, because the weather was different and the whole Earth was very tropical. So it's that question was answered, and then back into the future, when Antarctica was in the South Pole position, and it was first covered with forests and trees and whatever. The question was why the sudden enough change of weather that will freeze the whole place over and transform it into a white desert. And then again, it was answered because of the currents and the one thing brings the next, and it's like a cycle that in a way never ends until the modern ages, let's say, when we are.
Right. My questions were on that line also, because it's hard for us that we don't have a geologist view to think that the Earth has a tilt, and it's been as far as from the sun and the same position towards the sun as it has been. So it is really strange to think that the poles were not necessarily cold, right? It's that where you're also going now, is that you think, okay, if it's in the pole, it's going to be cold because it's far from the sun. The sun is never there, but there is a atmosphere, right, Viole, and there is an ocean and everything is connected. So not necessarily.
And the key word here is also the word that I can say easily. That is, I'm gonna ask to my carbon dioxide.
Carbon dioxide concentration.
That's, by the way, that's Ignacio in the back. He also is part of the Polar Travel Company.
Hola,
And
Ignacio.
He's helping me.
Why carbon dioxide?
See, we have a lot of volcanoes activity during. Imagine all these continents separating and breaking, and then activity. And volcanoes, what they do is to put in the air a lot of carbon dioxide and also other gases. Now we are talking. Now in our time we are talking a lot of this gas because we talk about this. Efecto invernadero. Someone help me with the
greenhouse effect.
Greenhouse effect, yeah.
Exactly. And it's the same. Different quantities. Yes,
different
it's not
source.
the same.
Instead of being human-made, it was naturally volcano-made or whatever, right?
Quantities are different now. Volcanoes, how much they can send to the atmosphere, but it's the same effect.
It's very mind-blowing.
Violeta, there's a question from the other Violeta in the room.
Okay.
But it's very interesting. Is regarding tectonic plates and the movement. Was it faster at the beginning? Do we know if it was faster at first and then it slowed down, or it was always constant? Is there any idea regarding that?
No. What they say, the scientific, is huge masses together in the planet, big supercontinent, doesn't work too well with the masses all together. So every time that we had a supercontinent, it's not something that is stable.
Stable, right?
That's the word. Yes, stable. So most of the time that the continents get together, nothing is fast in this in the Earth time, but they break down because it's most stable to be in different parts. I think that is something, an idea that we can see. You have a lot of weight in some point, yes, because of the dynamics of the internal different layers of the Earth. Is easier if they are distributed around the world. There was supercontinents that were for longer than others, yes, and that's the time that they were together or break up. It's not clear why, but it's around this idea that a supercontinent is not something that is stable to be.
That's very interesting.
Very, very good. Yeah, very interesting.
Bueno, Violet, thank you so much. I've ordered so many concepts with this icebreaker conversation. So thank you so much for your time, and thank you for everybody that came. I don't know if you want to add anything. Sorry.
No. I'm okay. I'm happy. More than happy. Yeah. It's great. Thank you, Violet. It's nice to see you again. It's been a while. And we are delighted to hear you. So
it's been a pleasure. And we'll probably have you again because we have a lot of questions about wandering icebergs.
Great. Yes. Okay. Bye to everyone. Thank you for listening.
So much.
It's been a pleasure.
Thank you so much. Bye, guys. Bye, everyone. Thank you.
Bye.
Bye. Thank you.
Bye.